Good morning, students. I welcome you for the chemistry class. Today, in this video, we'll be studying about solubility. It's a continuation of the previous video. So, I'll be studying about two questions, the problems based on that, and also about separation techniques. Okay, let us start with this. You can see the tabular column here. So, one column contains the temperature, the other column contains the solubility of copper sulfate. At 0 degrees, you can see 14 grams of copper sulfate can dissolve. So what will take solubility? It's for 100 grams of water, right? And at 10 degrees, it is 17 grams. 20 degrees, it is 21 grams. 30 degrees, it is 24 grams. 40 degrees, it is 29 grams. 50 degrees, it is 34 grams. 60 degrees, it is 40 grams. 70 degrees, 47 grams. So these is particular grams can dissolve at the particular temperature. So for example, 40 degrees, 29 grams of copper sulfate can dissolve. So if I cool the solution, so if I cool that solution from 40 degrees to 20 degrees, at per 20 degrees, only 21 grams can dissolve, right? So already 29 grams is there in that 40 degrees. If I decrease the temperature, what happens? Only 29 grams can dissolve. So rest 29 minus 21, 8 grams will crystallizes out, right? The solubility decreases. So such questions you'll get, right? So when you decrease the temperature, decreases the solubility, right? When 40 degrees has been decreased to 20 degrees, so 29 minus 21, so 8 grams will crystallizes out. So it will not dissolve, right? Separates out. The next question. So this is your textual question. So just follow the question in your text. Pragya tested the solubility of three different substances. Three different substances at different temperatures and collected the data as given below. Actually, there are four salts: KNO3, NaCl, potassium chloride, ammonium chloride. So four different salts has been dissolved and the data has been collected at different temperature. What is the solubility? So they have given this data in your text. So based on this data, the questions will be raised. Okay. So what mass of potassium nitrate would be needed to produce a saturated solution of potassium nitrate in 50 grams of water at 313 Kelvin? The solubility, we know it is for 100 grams of water. So that's a standard one. So potassium nitrate at 313, like 62 grams will dissolve in 100 grams of water. But here the question is for 50 grams of water, for half of that. Half of that, in the sense, it should be half of the grams of this, right? So it will be 31 grams. Or you can write the things like this. So mass of KNO3 to produce a saturated solution of KNO3 in 100 grams of water is 62 grams. For 50 grams, how much? So 62 into 50 divided by 100, you'll get 31. The next question. Pragya makes a saturated solution of KCl in water at 353 Kelvin and leaves the solution to cool at room temperature. So it is 353. So look for 353. And which salt it is? KCl. So look for KCl. So it is 54 grams. So when she reduces the temperature to room temperature, what happens? Decrease in the temperature, decreases the solubility. Yeah, the crystal of KCl will be obtained on cooling the saturated solution. So extra crystals will separate out. Third question. Find the solubility of each salt at 293. So at 293 you have to look for each salt. So it is KNO3 32 grams, NaCl it is 36, KCl it is 35, ammonium chloride it is 37. So which salt has the highest solubility at this temperature? When you look the value you can see 37 is the highest. So ammonium chloride has the highest solubility. You can look at the slide now. So each salt solubility you have to write and identify which is having the more value. So there's the highest solubility. Now, what is the effect of change of temperature on solubility of a salt? So when you take KNO3 or whichever the salt, when you just see the data, increase in the temperature, what is happening? So there's increase in the solubility. So that's the answer. On increase in the temperature, solubility of salt also increases. If you decrease the temperature, solubility of the salt decreases. So students, these are assignment questions for you. You have to write on the first two questions in your classwork. Please make a note. First two questions in your classwork, and third one you have to solve it in your textbooks. So copy table 2.1. So examples of colloids, and write any four differences between physical and chemical changes. Exercise question numbers 5, 7, 8, 9, 10, 11. So these are the questions where you have to solve it in your text itself. So no need to write in your classwork, only the third question, no, these questions. Next, we'll go with the concept of separation. Separation of components of a mixture. Heterogeneous mixtures can be separated into its constituents by simple physical methods, including hand picking, sieving, filtration. So there's a picture of hand picking. This is sieving. Filtration we'll be studying later. Now, let us go with the separation of two solids. How to separate two solids? There are some methods. First is using a suitable solvent. A mixture of a sugar and sand can be separated by adding water. When you add water, sugar dissolves but not sand. Upon filtration, you can see the sand will be left on the filter paper, and again evaporation of water, sugar will be left. It leaves away the sugar. Sublimation, second process. Here in this, there is a separation of a components which sublimes on heating from the other which does not. Thus, for example, naphthalene which sublimes can be easily separated from NaCl. Use of magnets. Iron is attracted by a magnet. Therefore, it can be separated from the other components of a mixture with the help of magnet. In factories, scrap irons is separated from the heap of waste materials with the help of electromagnets which is fitted to a crane. You can see the use of magnet here. So iron gets attracted. And this is sublimation process where you have already studied in the first chapter. So this was already sent through video recording. So go through that. And how to separate two immiscible liquids. Immiscible means they won't mix each other. So how to separate? There's a method called separating funnel. So what's the principle behind separating funnel? When a mixture of two immiscible liquids are kept in a separating funnel, the liquid separates out into two different layers based on their densities. Applications of that: to separate a mixture of oil and water during the extraction of iron from its ore. So this is a separating funnel. So when you add a mixture, you can see the lighter, denser one will be floating and the heavier one will be at the bottom layer. So when you open the stopcock, the heavier liquids will run down and the lighter can be in the separating funnel itself. So that's how you separate two immiscible liquids. The liquids which do not mix with each other are called immiscible liquids, and it's separated by a separating funnel. So pour some water and kerosene into a separating funnel, stir well and leave it undisturbed for a few minutes. Water being heavier than kerosene. So kerosene will form the upper layer and water will be the down layer. So place a beaker below the separating funnel, open the tap, the stopcock and allow water to fall drop by drop into the beaker. Close the tap exactly when all the water runs down. So you can see kerosene will be remained in the funnel. So this is how you separate two different immiscible liquids. Now, separation of solids from liquids by filtration. If a substance does not dissolve in a solvent, we say that it is insoluble. For example, sand does not dissolve in water. It is insoluble. Filtration is a method where you to separate the insoluble solid from a liquid. A mixture of sand and water is filtered. You can get the sand stays behind in the filter paper, we'll say it as residue, and the water passes through the filter paper, we'll say it as a filtrate. So you can have a look of this in this picture. So this is a residue and this is a filtrate, the filter paper, and we'll be using a funnel. So this is how the process will be done. So example, sand and water can be separated by a process of filtration. The next method is centrifugation. If you have a mixture of fine suspended particles and liquid, we can separate it through a filtration, but that is time consuming. So we use a process of centrifugation to rapidly separate the mixture. This is done by a machine called centrifuge. Centrifugation uses centrifugal force for the separation of two liquids in a mixture. Hence, denser components of a mixture migrates away from the axis and the lighter components migrates towards the axis. Centrifugation is a method of separating the suspended particles from a liquid in which mixture is rotated at a higher speed. Once the mixture rotates, a force acts on heavier suspended particles in it and brings them down to the bottom. The clear liquid, being lighter, remains on the top. This process is used to separate cream from milk. The next method is chromatography. It's a technique used to separate of those solvents that dissolve in the same solvent. It is used to separate the cellulose which dissolves in the same solvent in a very small quantities. The most commonly used is paper chromatography. This separation is based on the fact that two or more substances will dissolve in the same solvent, but their solubility may be different. The solubility rate may differ. How to proceed with the process? So take a thin, long strip of filter paper, draw a pencil mark about 3 centimeter from one end, put a small drop of black ink on the filter paper strip at the center of the pencil line. Let the ink dry. So when the drop of ink has dried, the filter paper strip is lowered into a tall glass jar containing some water in its lower part. The strip should be held vertical. Please note that through the lower end should dip in water, but the pencil mark should remain above the water level. When water reaches at the top, the strip should be removed from the jar and allowed to dry. The paper containing separate color spots is obtained. This is used to separate a dye from ink. So we know ink is a mixture of many dyes, right? So this is how the procedure. So you have to place water in a jar and then take a filter paper, mark around a pencil mark. At the center, you have to put a black ink and then place it in such a way that the black colored dot should not directly dip, right? The water level should be very much low. Then water starts with the capillary action, it starts moving, and that's how the dyes get separated, different colors. And remember, students, the one which is most soluble, easily gets soluble first, they dissolve and run at the top, right? And the lower spots is that which dissolves very late. So from this, you can separate a different dyes and also the pigments. Now, pigments in the plants, you can also separate that. And proteins, different amino acids which is present in the protein can be separated by this paper chromatography. So, thank you. We'll discuss few more techniques in the next class. Have a nice day.